then I'll just give a brief overview of what we're planning to do today. So we're kind of focusing on the fields of electrical, computer, and software engineering. And in between there's a kind of mechatronics engineering, which is kind of a hybrid of mechanical and electrical and software and computer engineering. It kind of brings all of them together. And then we're going to do a project about coding, and we have 3 guest speakers coming in today. So they'll talk about their experience in those computer fields, and you'll have a chance to ask them questions. And then we're going to do a project where I can break you out into, breakout rooms, and you can work on different kind of assignments around this hour of code. I'll go into more detail. So I just wanted to give you kind of an overview of today. The first thing we're going to do, though, is talk a little bit about engineering functions. And so let me get this presentation started, and we'll kind of go through it together. You probably already read about this in the book. The book goes over all of these functions, but I think it's always good to have the opportunity to talk about it with everyone, because there's always interesting things that come up. So when we ask this question of like what engineers do, it's such a wide-ranging response, right? So engineers can look at all sorts of factors in the concept of manufacturing, producing products, which would include things like cost, the efficiency, the reliability, the sustainability, the safety of things. And in order to make that all happen, we have to try things and test things in the environments we expect them to work in, but also in extreme environments. So like we've all seen car crash test videos where they're doing crash testing. And that's one example, but there are a lot more than just that. And so we're kind of always like in the cycle of improving things. And often when we go and look at the different roles that engineers can play in companies, it's wider than just kind of the, well, let's just go through them and then we'll kind of talk about how they all fit together later. So we have research engineers. And so research engineers are always looking sort of on the forefront of the industry, seeking new knowledge. It's kind of that boundary between engineering and science. There's certainly engineers that are always pushing that boundary. And you may be pulling research or relying on research that was done in the past, and it just finally has an application in engineering. So research is a place that people can look. It's a little farther away than other engineering fields in relation to, like the product, or, like when I was a researcher in graduate school, I actually am a part author of a patent, and we're still waiting for that patent to be picked up by someone, and that's already, oh my gosh, like 28 years ago that we wrote that patent. So, sometimes research will sit unutilized for a long time, but industry has a whole, they'll have research engineers that are looking out, like what is the field going to look like in 5 years? What does it look like in 10 years, even 20 and 30 years? They're looking out to stay competitive in the business environment. Then you have development engineers, and these are engineers that are, they're kind of using that, like we often talk about research and development together, and there's a kind of pipeline that goes from the research to the development. In other words, how do I take something that I can build in a lab or manufacture in a lab and turn that into a new product or a new technique or to just scale it up for mass adoption. So we're all kind of waiting for a coronavirus vaccine at this point. And of course, we're starting to witness some of that just as the discussions go on, because ordinarily all of that, we don't know what we're waiting for until it's already something we can buy. But there's a whole process that leads up to going from some research concept all the way into producing products and getting it on the shelf. Design engineers, which focus mainly on like design and engineering. We kind of have the function of something, and bicycles are a really good example where we all know sort of the functionality of a bicycle, but yet there's so much variety in the types of designs that are used, the advancements within bicycle design. So, at one time bikes, there was a period of time when mountain bikes were evolving, and that was a very active period of design. And so now people, maybe a lot of design choices are not made out of like a functional need, but sort of a cultural need. But it all leads into the details that end up in the actual product, so like bikes are a good example, but even phones, right? There's so much variation in the design of phones, and over your lifetime, you've probably seen the design choices change, while the core functionality of the phone advances, but maybe not as much as the design. Test engineers, they're responsible for basically making sure the products that the engineers design through the research, development, and design phases actually function as expected. And test engineering is really, it can be a really fun place. Like when I was working in industry, it was the testing engineers that really had almost more power than the design engineers in how things were put together, because they were the ones who found the problems. And when you discover a problem, you have to solve it. And so there's a tight feedback between research, development, and feeding that back into the test engineers. So for example, when we think about 1%, right? 1% failure, that doesn't seem that outrageous, but when you're talking about 1 million products, a 1% failure rate means 10,000 failings. So when we are engineering, we're engineering for like 0.0001% failure. So that comes with a lot of work of a large team of engineers to verify our designs against the criteria we set for their safety, their response in extreme conditions. We see a car crash here, and of course that that crash testing is what has really made cars safer over the 100 or so years that they've been developed. You can function as an engineer sort of in this business, marketing, and sales pipeline, I would say. And some of that can be like working very directly with the clients. So we're often thinking about engineers as, making products, but we don't always think about engineers in terms of selling products. But if you think about in industry, like, let's say that in like the semiconductor industry, there's a huge industry that is not about designing chips, but about designing the equipment that makes chips. And so that is such a technical, esoteric field. You're never going to sell those to a consumer, but you're also, when you're selling a chip making piece of equipment, you're spending millions and millions of dollars, literally millions of dollars, on these pieces of equipment. So they're not going to just hope that it works out. They're going to have a whole team of engineers from both the company that's selling it and the company that is getting integrated into their manufacturing to make sure that it fits within their whole system of their current system of development. And so this is a really interesting field if you're an engineer that is sort of extroverted. You like to work with people, you like new challenges, you like to travel. Business and marketing and sales is a great kind of field for engineers that like that kind of experience in life. Field engineers. So, you know, these are engineers that when we think about designing a building, there isn't just a complete disconnection between the design phase of that building and the construction phase. There's often engineers that are kind of being the liaisons between the construction teams and the design teams, because things come up. Sometimes you find unexpected situations under the ground. When you're building a skyscraper, for example, you're basing that on an assumption about what the earth looks like underneath it. And sometimes you have to make decisions along the way. So they're always kind of negotiating that. And of course, this, you know, this is sort of betraying some of the truth about the wider field of engineering and how big these projects are and how many people are involved in them. And so there's lots of different roles that you can play. Of course, a lot of engineers end up moving into management, and the role of like a technical manager is often very different than the role of an like an HR or a human resources manager. So management can be about not designing products, but about coordinating them, or like building the whole kind of team of people that will build a product and making sure everyone's projects are coming along so that they can all come together into a final delivery, whether it's software, you have a software release, it could be a new design of an automobile, but someone has to coordinate all that. And a lot of those managers came out of the engineering ranks. There's a lot of engineers that work in, again, sort of behind the scenes. You know, what is it that is required to produce? Oh, here, I have, this is one of my vices, are these trashy, sugary candies. This is bottle caps. But like sweet tarts or any of those things, right? We don't think of this as being engineered, but this whole package, like some machine basically took this plastic, wrapped it around 3 pieces of candy, you know, fused the ends closed, and that's all design. That's all, you know, there's people designing the machines that do that. They're designing the processes, and a lot of those processes involve human beings. A lot of times there's safety systems built into those machines. And so there's a whole other layer of engineers that work in sort of behind the scenes doing the magic. And then quality control and quality assurance engineers that are making sure that the products that finally that we produce are meeting our quality standards. And in a modern environment, quality control and quality assurance engineers often work with what we call vendor products, right? So when you think about how a car is manufactured, there's a lot of different companies that are involved in producing the tires, the wheels, the, you know, the drivetrain, the engines. They're all coming from either different companies or from different parts of the same company. So you wouldn't just take it on faith that because I got a big delivery of ball bearings that they meet the specification. You actually test them to make sure that they meet the specification, because they're going into a product that you put your name on. So this is another huge field of opportunity for engineers. Safety engineers, obviously, like concerning themselves with the safety of things, like what happens when things go wrong. You know, a lot of engineers think about not when things are going right, but what happens when things are going wrong. How do you mitigate the impact of things going wrong? Whoa, that was bad to scroll the wheel. So I think you guys already, I talked to Preeti and she said that you guys already talked about this slide, but you know, engineers really have the opportunity to do just about anything they want. Engineering provides a great technical foundation that can be applied in so many different contexts. So you can start as an engineer and start to do law, because if you know the technical aspects of patents, or you know the technical aspects of products or science, you need that expertise to be a patent lawyer, because if you don't know that, you can't write a good patent. Business, management, healthcare, all of these things, like you can work your way into those industries, and it's a really great place to start. And it's not a kind of dead end job. It keeps kind of expanding out. So let me see that there's a question in the chat. Okay. I'm going to stop sharing so I can see you guys. And I will try to field any questions that you have at this point. I'm trying to pause so you guys can have a chance to think and ask a question. The main story here is, don't let your kind of mental image of engineers and their role in a company be very small. Like it's an opening to basically play almost any role in a company. And there's a lot of like kind of competition almost between the teams of engineers. So, you know, the test engineers definitely take some pride in breaking a product that the R&D engineers thought was unbreakable, you know, and that's what makes things better and makes things safer, because they're really trying to outthink you and think like, you don't think a person will use this in this way, but they will. And when it, you know, it better survive that. So it's a kind of fun environment when you kind of have this internal competition going on with the different groups about, you know, making something and making it survivable, making it safer. And, you know, it's pretty interesting. And towards the end of my career, I got more into the sales engineering role, where I was visiting different countries and going to see our clients and seeing what they were doing. And that's always really eye-opening to see where, you know, your product is being used in another industry and how they're thinking about it, because it's almost inevitable that your idea is smaller than the real world actually is, and the way that it might use your product is always bigger than you can imagine. So it creates this great eye-opening, you know, experience of, I never thought, you know, this would be used more than 100 times. And then you go into one company and it's used 1,000 times in 1,000 different ways. Anyway, I won't belabor that any longer, but we did want to give you that kind of preview. And then there's in the assignment this week, there's a little bit of a discussion around that. Okay, so I'm going to tackle the next set of slides, and we will have our guests probably start popping in pretty soon. Let's see if anyone came in yet.
Hey, Carl, can I ask you a question about your engineering descriptions?
Yeah, of course.
So I'm wondering, you were talking about, I believe, a design engineer, and I was thinking about what they did versus something like a industrial and systems engineer.
Yeah.
Can you tell me a little bit more about the differences?
Well, a design engineer may satisfy like I'm trying to think of something that's heavily designed. Like if you think about automobiles, like there's always like a few cars out there that are kind of weirder than all the rest of them. You know, like at one point there was that, what's the Cube? Isn't there like a Cube car? It's called the Cube or something like that. Somebody remember that car? Anyway, there's
That's
often
PT
technical
Cruiser.
challenges in actually achieving like an artist's goal. So you might have an artist or a designer that is trying to, I don't know, I'm going to pick up these headphones. This is contrived, but let's say that they drew this and they said, I really want this to look like this. But then when the engineer was trying to design this metal part, they found out, well, it's hard to design something that looks like that because of some technical aspect. So they're challenged with doing that. So if you look at architecture, architecture is one of those places where the kind of aesthetic design is much more challenging to actually manufacture than if you just wanted to function, you know? So you actually have to go through a whole phase of like, how do I achieve these aesthetic goals um, uh, without sacrificing the kind of functional goals as well? So they liaise between those two teams. And so, like I said, cars, you know, you'll have a body type. A lot of cars, companies will design sort of some infrastructure, like here's a chassis, and then there'll be different bodies that go on top of it, and they adapt them to different kinds of vehicle types so that they're not, but there's a lot of work that goes in like making those things fit together. And it's not just artists, it's basically that the connection between the functional engineers that are designing something that does a particular function. I don't know, here's another one, you know, it's like, if you go look at voice recorders, I have a voice recorder. There's challenges in making it look exactly like this, in laying out the buttons like this. And so a lot of times the design engineers are doing that work to integrate with the kind of more art or design oriented employees of the company. Special effects are really, you know, like you can imagine like special effects is one of those challenges where there's a design that you want to implement and there's a whole bunch of technology that gets between that, you know, drawing of a particular alien creature and actually producing that in a physical model that involves a human being still being able to breathe and move and do all those things, you know. And that's an extreme example, but I think it kind of gets to the heart of that design engineer work. Other questions out there? All right, so I'm
Actually,
gonna
sorry,
delve. Yeah,
sorry, Carl, I have one question
of course.
about the different fields. Do engineers tend to get kind of pigeonholed in one field, or will they, or functions, or will they tend to navigate between? Like, if you have an interest in doing research, but then moving on at some point to design, so you can get your hands on projects, are they able to navigate between fields within projects, or from one project to the next, or?
Yeah, certainly, you know, and oftentimes that comes in kind of moving from one company to another. Like sometimes you do get pigeonholed in a company, but those pigeonholes kind of disappear when you leap out of those boundaries of a particular company. So, but it's not unusual to move from one, like being a test engineer or a quality assurance engineer to an R&D engineer. At least that wasn't unusual in the software industry at all. It's kind of like you gain skills on the job that then make you more valuable in this other role. So there's kind of an evolution in the career of every engineer that kind of goes, you know, paying the dues and all of that, the kind of lower level jobs, and you work your way up. And at some point it becomes harder and harder to do that, not just because of like a constraint of the system, but you become constrained by your interests, and you found the role you really like. Like, I don't really like dealing with the schedules of a product. I hate it. It makes me crazy. So I'm going to work as a research engineer where I don't have to meet the same kind of schedule targets as someone that's supposed to ship a product on October 10th, you know. What you're trying to do is figure out, how do I make a chip that runs 3% or let's say 30% faster and uses 10% less electricity, or, you know, I'm kind of making these up, but there's different constraints and different pressures on the different groups. And R&D is a little bit away from that kind of business aspect. It's sort of we're just investing in you. I hope you find something that will keep us running for the rest of our lives. But so it is possible to jump from field to field.
Okay.
And you'll find fields you naturally like and ones you dislike.
Cool. Thank you.
Add something to that.
Yeah, of course.
So I spoke with an engineer from PG&E yesterday, actually, for the upcoming project, and something to add to what you're saying is he said within PG&E, he said there's so many different departments you can switch to as an electrical engineer. He said for his department, he's working with transmission and distribution, so he does things with schematics and blueprinting out how transmission lines are going to leave the substation, and another department handles, you know, from a nuclear reactor or whatever to that substation. And even within that, there's different design teams, and he said it's such a big company that there's so many departments you won't get bored. He said his previous position was doing more field work, like he would go analyze the lines and go check out different tools and what they were doing, so he got a lot of field time. And then his new position's more schematics and design. So I was
to the north.
That's one of our guest speakers, by the way.
I was gonna say, dude, your mic's on. So, yeah, that was something interesting that I found to add to what you're saying is within that department, and that of course is union, so that you can even move anywhere in the state you want and still be employed. And you know, I didn't realize before they had that many departments you could switch to within a company. I used to think it was very static, like if you're a design engineer, you're only doing this at this company, and there's no room to move anywhere. So that kind of opened my eyes to, you know, there's a lot more possibilities than I thought, you know, and that's just for power. It can extend to like making power systems for computers or chips, you know, to electronics and households. So that's what I learned.
Yeah, thanks for adding that. And I'll talk a little bit about that project, the interview project, and how we're going to try to share the information that each of us gleaned with everyone else. The other thing that you triggered me to remember is that oftentimes your career will kind of move in parallel to your personal life as well. So, you know, as you maybe pair up with someone and have children and start to have a family, you will naturally make choices about your career that allow those things to happen, right? And so there's a little bit of a kind of interaction between your personal life and your professional life, and the system is designed to accommodate those things, you know. So you'll have maybe periods in your life where you're not working a normal 8 to 5 job, but then other times where that's the most important thing to you, and you'll find those jobs as well, where, you know, engineers don't always have to work. I don't know if you've seen that show Silicon Valley, but you know, it's not always just a startup with crazy kids and mayhem going on. You know, those do exist, but other times you want something that's more stable, that has a steady timeline, not these intense periods of, you know, workaholism and other things like that. You can find just about any kind of lifestyle you can imagine. It can be supported by some sort of engineering field. So with that, I think I'm going to hand it off to Josh, and we'll just let Josh introduce himself, talk a little bit about his experience at Cabrillo and transitioning from Cabrillo to the working world. And then we have a couple other speakers coming in at times, and then we will allow you to talk to them too. So Josh, it's yours.
Oh, cool. Awesome. So anyways, yeah, I graduated from Cabrillo about in May of 2015. And my course or my career is like accelerated ever since. So I went to San Jose State University, and I've actually worked at NASA. That's like my senior year. I was actually interning at NASA, and I've met some amazing people while I was working there, and it's been like, it was actually amazing, like the group of fellows I've met. I actually met the guy named John C. Mathers. He's actually he actually won the Nobel Prize. And then I also met the director of of NASA Goddard. He actually is not actually working anymore, but he actually is working at he's the head of the National Reconnaissance Office, the head of the NRO now. He's actually a really nice fellow, and to what he's actually like for his position now is he actually had to get elected in from all the 100 senators, and so that's his position now. Is he's the head of the National Reconnaissance Office. He's probably like the boss of probably like, I don't know, 500,000, maybe 1,000,000 people. He was a really nice guy. I met him personally and everything. So that's why I did at NASA. Actually, I actually went to mission operations while I was over at NASA. Mission operations of the Hubble Space Telescope. I've was at mission operations of Mars rovers. I've been the mission operations of a thing called NEAR, which is satellites that actually go like there are certain satellites that actually go around like close to Earth, like really close, like they're monitoring weather and all this type of stuff, and I also saw the computer systems for Voyager 1 and Voyager 2. So I saw the computer systems that are recording data from 1970-ish. So it is kind of cool. So after NASA, I went back to San Jose State University, and I graduated from there. And as soon as I graduated, I actually got 2 jobs. One was working at Barracuda Networks as a software engineer, and my other job is working for the Department of Defense. But to get my actual job for the Department of Defense, it actually took a while. It took 1.5 years for my security clearance to go through. But during that time, I was actually working on at Barracuda Networks. I was working on basically AWS, Azure, all these cloud technologies. I was also working on VMware and Hyper-V and all these virtual machines, and it was a very good experience. I had a very good boss, and I kept on learning, and yeah. So, but everything I'm doing now, like I've progressed into my actual job is working over here at the Department of Defense, and everything I'm doing now is actually classified. Before I could actually come here to speak to you guys, is like I had to let a boss know that my intentions and everything, and I actually have a clearance review like of everything I do, like, and everything before I could actually explain like that I can be here. But I'm glad to be here, and I'm here to answer any questions and
So we have one, which is, what degree did you get?
Oh, okay. Yeah, I got a software engineering degree from San Jose State University. So,
And how many years were you at Cabrillo?
I actually spent probably about 3 or 4 years at Cabrillo. Cabrillo is a tough school. I mean, but I learned a lot while I was there. I mean, it really prepared me when I transferred to San Jose State University. Like I felt like I was trained in this and that, and when I transferred, like I was prepared when I transferred. Because once I transferred, like I was actually able to like excel in my classes. So I was very well I felt good about myself. So
Yeah, we actually have a lot of data that San Jose State sends us, and a lot of our students, actually statistically, our students do better than their native, where the students directly transfer to San Jose State from high school.
yeah, I felt that
Yeah.
um, like one of my closest friends I came to like went to San Jose State. Like I met her and like we became friends. Um, she was from Saratoga area, and but like I, I asked about her like 2 times to one. Like she's just in there asking me questions and everything. It's like, oh yeah, you need to do it this way. You have to think about this way and that way. So, but yeah, I felt very prepared once I transferred. So,
Other questions out there? You can either type them into the chat or you can just unmute yourself and ask.
How did you like the engineering program or just department? Because I know you did software. How did you feel at the atmosphere was at San Jose State?
actually, Cabrillo College was much better with me learning my stuff, like for engineering, because the STEM Center was just so supportive and you could learn from each other. And um, once I transferred, like there, there's no STEM Center over there. This is like you learn by yourself and you just do your thing, you know. So like I felt like I learned a lot more while I was over Cabrillo. I really did.
All right.
What about extracurriculars that you did along the way?
Okay. Just your engineering abroad. um,
You read my mind.
oh, I was there. I remember. So, anyways, while I was at Cabrillo, I attended engineering abroad, and we went to Guatemala and all that type of stuff. And we were working down there and installing potable water for a remote village outside Antigua and all that type of stuff. And um, that was a great experience. Also, when I was at Cabrillo, I was also the treasurer of the student senate, and I was also treasurer of engineering abroad, and like, you know, as a treasurer of like these activities, you know, it's really good to, you know, have good involvement of the activities and everything, and yeah. So I mean, like I worked hard, and I tried to apply like my skills and try to be involved with the activities on campus and everything, and yeah, so so
Other questions out there? Otherwise, I'll keep asking them.
Did your study abroad help you when you transferred? Did it look good?
you know, actually, when like my study abroad was like an experience, and it helped with during the like interviews. Like if you have certain experiences and you could sit there and talk to people, and it mostly like what you want to do as an engineer, you want to be able to communicate, work as a team player, and do this type of stuff. And like during the interview, it actually gave me like, okay, this is what I have done. This is also what I can do. And then, you know, it's just an experience, and it's a talking point to the person you're interviewing with. I think that's the most important thing. Like you can set yourself up with interviews and stuff, but like if you can communicate and talk back and forth to the ones interviewing you and have a talking point, I think that's a really good factor getting actually hired into your position.
Yeah, I saw that they had this study abroad program, um, and I was interested in it, so that's why I wanted to ask you about it and how that went. Was it like a full summer? Was it just a few weeks or a month?
Actually, like it was a year-long program. We
Oh
only
wow, okay.
actually we only went to Guatemala for a few weeks during
Mhm.
the winter side of things, but um, Joanne like pushed us to do everything and work hard and like make our plans beforehand and all this type of stuff. And um, yeah, I actually learned a lot, and um, I made some great friends.
How
And
was
it, go ahead.
how was the experience as far as did you run into language barriers? Did you get to interact with the locals and see the impact you were having? Um, Maybe gain a better understanding of the importance of the field, sort of thing, or
Um, there was enough people that spoke Spanish while on my trip and everything
Mhm,
that they actually interacted with the locals
mhm.
for the most part. But yeah, I really didn't see that much of a language barrier because I was so close to the people that I went with, and
Mhm.
so um, it's easy to talk to like my friends and the group and everything. And I did learn a little bit of Spanish while I was down there. But yeah, it's just it was what it was, you know. It's an
Yeah,
awesome.
I've
So
that's good to hear. I've been out of country a few times, and it may not seem like it, but I know a few weeks can make a huge difference and give you
yeah,
quite an experience. So I'm not discounting that at all. But thank you for sharing about that. I was curious because it's something I'm interested in.
Yeah, I'm absolutely happy to talk about the engineering abroad program um, in more detail at other times. Like, there's kind of like a semester of preparation, and then there's the trip, and then usually we have the students put together a presentation and go talk to the funders and try to make connections out in the, because there's all these professional societies that we've kind of introduced you to, but there's a lot of local branches of them, and they'll give us money for students to go on these projects. And so we kind of take the students back to those groups so that they can have that one-on-one communication and, just one of the things that I think is one of the most major aspects of it for our student body is that you don't realize your position in sort of the intellectual hierarchy of the world, that it's an accomplishment to be in this class. Like our society sort of shrugs it off and says, oh yeah, you're in college, big deal or whatever. But that in a lot of communities in the world, that is an incredibly huge deal. And the skills that you can put together can change communities. When Josh went, I think Josh, you went the second year, is that right?
that's correct. Yes.
So when we were installing these water projects, 5 years after that, the school demographics went from being 20% girls to 50% girls. And you wouldn't expect that changing the water, the availability of water in the village would do that, but that is a direct result because those girls are no longer hiking 2 or 3 hours a day, you know, getting buckets of water for their family. And it totally changed the demographics of the school. So there's like the personal experience, but then there's also like the the ability to actually make like change. And sometimes it feels pretty distant in our society because we have all of these regulations and things that prevent you from sort of functioning as an engineer until you're an engineer. Anyway, well, I'm happy to talk about the engineering abroad program.
Yeah, I also wanted to mention is the first like 3 years of the team leaders were actually women. So like they actually led the whole engineering abroad program too. So you know, it wasn't sexist, it wasn't this, that, or anything. It's like we learn from each other, and we were just trying to study and build a good system for what we're trying to do. You know, it wasn't trying to be we weren't trying to be like like on top of anyone. So I mean, we're trying to do this as a team. So.
Any other questions for Josh? Otherwise, we can let him take off.
I have one. Josh, have you ever been faced with something that, let's say a project that you have to do and it just doesn't go along your morals? Like it doesn't go along with, I don't know if I'm explaining myself enough.
Yeah, I kind of understand what you're saying. I'm trying to explain it, but like lately, like my job has been so classified, I cannot actually give you any details about it, unfortunately. So, I mean, like, here's the thing: is like, there's always a certain goal for the team, and it's not exactly like what you wanted, but it's just like, this is how it happens, you know, this is what we want, you know, you have to provide for whoever you're developing this anything you're doing for, you know. It's not like it's you're not trying to hide from you what you're trying to do, and you just want to accomplish your goal. So and so that's basically, I mean, it's a bunch of little things that add up to a bigger thing. So yeah, so that's basically how I can explain it. I mean, I'm not trying to yeah, that's basically it. So I'm sorry.
We're going to do a section later in the semester on ethics, and like ethics and morals are slightly different, but there are, you know, like some of the questions are complicated, and there's a whole, like the professional societies and kind of the profession itself takes stances around certain issues, ethical issues. And you can safely work in engineering without overstepping those ethical issues, you know, so I think there's a little mystique that comes with the classified environment that makes it seem like you must always be confronting an ethical or moral boundary, when in fact it may just be that this is something that we don't want our adversaries to know about, so we don't talk about it. And it doesn't necessarily venture beyond that. And I know you can't really talk about that, Josh, but you know, there are all sorts of examples of, you know, kind of like making the best of it. One of the examples we do in the ethics discussion is, you know, landmines are a kind of problem in post-war environments. So these fields get mined, and then years and years after, those mines are still alive. And so, you know, is it ethical to work on a different kind of landmine that can disarm itself so that those civilians tens of years later are not vulnerable? So, you know, there's like a complexity to it that often that we don't always encounter in sort of the everyday work, but oftentimes when you're in it, there's a whole kind of like structural foundation for the ethics of engineers that protect you from being out on your own in a kind of difficult situation. Other questions for Josh? Otherwise, we'll let him go.
Yeah, hi, I had a quick question.
Go for it.
Thanks for speaking, Josh. Since you transferred to San Jose State from Cabrillo, and I know a lot of students do just with the close proximity and relationship, is there any advice that you wish you had before you transferred after you graduated from Cabrillo? Maybe education-wise or non-academic, like you really look at housing, or, you know, Cabrillo's admin might be a little bit more receptive and better than San Jose States, and just something that you think might make it easier for everyone if they were to transfer over there?
When I transferred from Cabrillo, like I was totally compared, like academic wise. Um, like like I felt like I ran loops around the people that actually were there actually. With as far as my training and my education, but as far as when like travel, I actually travel myself. I actually drove my motorcycle from Pelton, California, and sometimes it's kind of scary because I felt my tires like skidding on Highway 17 in the middle of the rain and all this type of stuff. And, but I actually commuted over 17 to go to San Jose State University. So I can't explain like that for housing or in that aspects or anything. But like I know if you wanted to like do housing over at San Jose State University, it would cost you probably, let's see here, the tuition would be about 15,000 a year. The housing would be about 25 to 30K a year. So like I know the housing is expensive in San Jose, but I kind of avoid it myself. So that's why I did. I just drove there. Yeah.
Thanks, Josh.
I've got a few more questions,
Sure.
if you're
You know
able.
what, our other guests have showed up. So I think maybe what we can do is let Julian talk a little bit about his experience, and then we'll take more questions. And Josh, you could stick around if you want, but you could
no
also
worries.
take off.
Yeah, I'll be here. Don't worry.
Okay. Julian, do you
Hey
mind?
everyone.
Oh, awesome.
Yeah,
Thank-
no problem. Sorry, I got caught off in some baking timing issues. So I baked too much bread, so quarantine. Anyway, hi everyone. I'm Julian. I will be settling down in just 1 second, but if you don't mind me walking around with the camera, that's fine. I am electrical engineer, went to Cabrillo, transferred to UCSC, and then let's see, went to UCSC, worked in the startup space for about a year after that, and then I've been at Cisco Systems for about 7 years now. I was taking a little off guard here. I'm an international student. I'm from France originally. I came here about when I was 19, went to school, and I live in Santa Cruz now. I work on the manufacturing side of the telepresence systems for Cisco. So anything from IP phones to telecommunication systems to headsets and stuff like that. If you guys have any questions, or I can go more into what I do or more into my path. I don't know where we want to go from there.
I said, I want to know about your shirt.
Oh, it's Yo soy tu padre. So it's Dia de los Muertos and Star Wars at the same time. So
Very cool.
I got a quick question, Julian.
Go ahead.
Oh, sorry. So how was your education experience at UCSC in terms of the quality of the engineering instruction, as well as also like the community or the faculty life as far as your education?
Yeah, so that's a great question, and I kind of echo Josh's thing of running laps around the kids over there. I did circuits, I did all the lower division stuff at Cabrillo, and I found that there was a much more of a direct and better teaching from smaller classes and professors who actually care at Cabrillo, especially for lower division. That's what I'm talking about for the basics, the things that you need for every single class. When I transferred, as Josh said, I was running laps around people on circuits I was bored in my transistor class because we had, touched things at Cabrillo differently, and the basics and the understanding that I had when I transferred was much deeper because of I think Cabrillo is one of the best colleges out here. Transferring after, once we get to larger upper division classes, there's no comparison because they don't exist at Cabrillo first, but also the classes got much smaller and the professors actually started caring about teaching those classes because it's more their field of study and not amphitheaters of 200-300 people that you can't really meet anyone. So my takeaway from that is basically take as many lower division, as many classes that will qualify at your whatever next university you're going to go to that will work. Like I even would recommend, if you can, still take Cabrillo classes while you've transferred. It'll cost you less money because you will pay Cabrillo credits versus your college's credits, and then as long as they transfer, you'll get a better baseline there.
What college
Okay.
were you?
Cool.
Well, as a transfer, I was college. I think it was college 9, but it doesn't matter
Ooh.
because you don't do anything for your college because you come in as as a third year. So your college, you don't live on campus, you don't live at your college. The only times I went to my college was to get my new sticker for the bus. That was once a semester, and that was it. I lived in the engineering building. Like that's what you end up doing. So.
And what programs did you participate in? Any programs or any clubs up there?
Yeah, I ended up being vice president of IEEE and treasurer of Tau Beta Pi, which is, you might not know that one. It's the Engineering Honor Society. So it's not a club that you can join. It's a club you get invited to based on your GPA. So anyway, I was treasurer of that. And then, well, one of the big things that I took from UCSC that was great is our senior design stone projects, because they did, and I still think they do it that way, a different style of capstone, which was corporate sponsored. So we actually had money and we actually had a real project. And the way it was built was designed to be completely like a real engineering project, in the sense that, sorry, something's burning. I'll keep talking, but since it was a real engineering project, the class was, we didn't really we had a grade at the end, but ultimately it was more about reports and Gantt charts and planning and budgeting and team relations and how to work in a team. And that experience really gave me a leg up when I was interviewing, because especially when you interview at a low level, is your first job, everyone showing up in front of an interviewee has the same experience, has the same qualification, right? You're all first year graduate. But if you can talk of internships or projects that you've gone to that have real life application of, hey, we had a conflict with a team member and this is how we resolved it. We had a project and this is how we went ahead for a whole year to plan that project and figure out how to do it. And we ended up getting a patent out of it.
Nice.
Everything we do is we have to work in teams, and it's actually not about us, it's about the team and our progress and everything, and that's where our focus is like we have to be able to work as a team member with and have good relations with other people. So I encourage you to work about like any projects you have with your friends or your other classmates and everything. Working in the STEM center. I mean, Cabrillo College was awesome. Like for my training, like I learned how to do everything.
I learned how to learn.
Yeah, Julian actually took circus, and I actually took circus as well at Cabrillo. I mean, and I'm so glad I did it at Cabrillo because, like,
Did you take it with Carlos?
I did.
Of course.
Yeah, I mean, Carlos was awesome. He recently retired, so, but
No, he's still there. He's still there.
He's still there. There is a new scholarship under his name that's
Yeah,
being set up.
I actually funded it too. I gave like
Yeah, me too.
nice. But yeah,
Carlos was at my graduation of UCSC. Like that's how big of an impact that professor made on me. So.
Well, yeah. I mean, the whole engineering department is like here with you no matter what. Joanne is freaking awesome. No matter what, she pushes you and pushes you and pushes you and pushes you, but like in the end, like she has good intentions for you, and like it's a struggle all the way to the end. But it's like in the end, it's like holy crap! Like I'm like I felt like I was the smartest person in the world. But yeah, Carl is awesome. Joanne was awesome. I mean,
is Joe McCullough still over there?
Oh,
yeah.
yeah.
He's the one who got me into engineering because I had to take a physics class, and then when I transferred from France, I didn't really know what I wanted to do. Came to Cabrillo, and then I took a physics class with Joe, and I was like, oh, well, that makes sense. And then that's where I became an engineer. So Cabrillo gets you there.
Yeah, so Hannah arrived, so why don't we let her introduce herself?
Sure.
And it's like we have the band back together.
Yeah, thanks, Carl. Yeah, let me give a brief intro to how I ended up where I'm at, and I'll tell you guys where I'm at too. So my name's Hannah Homer, and I realized last week when I presented to the last class that I was in your shoes, your exact shoes, about 10 years ago, which is really hard to believe because the time has just flown by. But to give you guys some background, right at that time when I started going to Cabrillo, I had just graduated from Harbor High School, and I think at the time I didn't really quite know I wanted to go into engineering. Actually, mid-high school, I really wanted to go to art school, and that was about in the 2008 time frame. And at that point, you know, I really liked doing art, but I realized no one was going to fund my dreams of living in San Francisco and going to art school. So I wanted to find some sort of career that would allow me to make a good salary. And at the time, I had associated money with the Bay Area and tech and engineering. And I didn't really know exactly what I was signing up for, but I was really determined to get through some of these math and science classes that were needed for engineering. And those classes definitely did not come natural to me, but what I did like about those classes is the challenge. I was able to, you know, go into this really, you know, maybe scary math class, and I was able to, you know, study, get help from others, and ended up getting through that class with a fairly good grade. So that's what I liked. I could put in effort and get something out of it. And I didn't really know any engineers personally, but I just kept going through these classes and getting through them. And eventually, I chose to go into electrical engineering. And I think this was partially motivated actually by Carlos Figueroa, just because I liked physics 4D with him. And it just seemed like something that would be a good path, especially because I liked gadgets and you know, different consumer electronics, iPhones and things like that. And I thought, well, maybe I could go into designing something like that. So I was at Cabrillo for about 3 years, and then I had goals of, you know, eventually transferring, and I applied to Cal Poly because that was a school that was recommended to me. And as a backup, I had a tag agreement with UC Davis. And I think at the time, you were guaranteed an acceptance into UC Davis as long as you had a GPA of maybe it was 3.1 or something like that. That might have changed. And if you had taken, a particular amount of classes for engineering. And I ended up getting into Cal Poly, and I'm really glad because Cal Poly was also a really great experience. It was actually very similar to Cabrillo, where there were small class sizes, the labs were hands-on, the teachers were approachable, and I got a pretty good study group together at Cal Poly with a lot of other transfer students, and went through Cal Poly in about 4 years. Although I should say I was there for 4 years, and I probably could have gotten out in 3 years, but I went through Cal Poly for my bachelor's and my master's. They offered both, and they offered this accelerated program to get my master's in a year. So overall, I was in school for about 7 years total. And then after that, I got hired. Oh, actually, let me backtrack a little bit. So while I was at Cal Poly, remember I mentioned that I really like consumer electronics. So my goal at Cal Poly was to get some internships in that field. And sure enough, my first summer after being at Cal Poly for a year, I interned at Amazon, and I worked on Kindles. And then my second 2 summers, I interned at Apple, working on Apple TV, which was also a really cool experience, actually getting some hands-on experience working in those teams and seeing what it's like to actually apply all the stuff that I learned in school. And then after I graduated, actually maybe 6 months before I graduated, I got a job offer from Intel up in Portland, Oregon. And I accepted that because I wanted to live in a city, and I liked the idea of getting out of the Bay Area after all that. And that's where I'm at now. So I work at Intel full-time as a power electronics engineer. And I work in the data center group. So to kind of give you an idea of what I do, so all of our chips require power. And it's not so simple as like maybe what you think of when you think of powering your laptop, where you just plug in one cord and your computer powers on. It's actually pretty complicated. When you think about like your laptop, for example, there's sometimes nearly hundreds of different power rails at different voltage levels, different current outputs that are in your laptop, and same thing with a data center. So I design all the power supplies and all the boards, anything that has to do with power is what I'm working on. And I think that it's a pretty important job, especially right now with so many people online and using services like Facebook or Google, for example. And there's a lot of people that are accessing information at the same time, and there's a large power draw, and we have to make sure that our power is stable, no matter what your workload is. So I get a lot of personal fulfillment off of what I do on a daily basis. And I didn't mention this during the last class, but I just want to highlight, even though I wanted to go into art back in high school, I still feel like I'm able to do really creative work, even though I'm more on the technical side. So if you're thinking that you're more of a creative thinker, you're not sure if you're going to like engineering, you might think it's too numbers-based, maybe too methodical. There is opportunity to be creative, and depending on where you go, maybe there's different levels of creativity, but I'm very happy at Intel. Another thing that I wanted to mention is just the return on investment, as far as how much money and time you put into school, you definitely get that back with engineering. I think nearly all of my graduating class had jobs that were high paying right after they graduated. And I know that that's not common with every field that you can go into out of college. So that's another thing that I wanted to mention, because I know these classes are really challenging, but if you can just get through it, there's, rewards at the end. So I wanted to mention that. Another thing, just as far as advice goes, as things get more and more challenging, my advice to you guys is to just stick with things and ask questions, go to office hours, and use the services that Cabrillo offers, such as Mesa, MLC, PLC. I'm not sure. I think they're all still there, and hopefully doing some sort of online tutoring. But yeah, it's really hard to get through engineering by yourself. It's definitely a team effort, and if you guys can practice collaborating and thinking with others, asking them questions, that's really going to pay off later on down the road. So I just rambled for who knows how long. So I hope that kind of gave you an overview of who I am, and maybe you got some 2 cents out of that about how to get through this. And then yeah, if you guys have any questions, I'm happy to answer.
I actually like to comment on that. It's like it doesn't really matter about anything. Like if you want to be an engineer, like it's a helping profession. You're sitting here trying to solve problems, and you're working as a team to solve these problems. And like even if you get into engineering department at Cabrillo, like work with your classmates. I mean, like you're solving the same problem. Cabrillo was awesome for me. I mean, like it really actually studied, or I actually learned so much from Cabrillo. Like my work ethics are awesome, and I learned a lot while I was at Cabrillo. So.
Yeah, I think the quality of education is great at Cabrillo. Go ahead. Someone was about to say something.
Well, I was just, one of the things that, when you were talking, it reminded me that engineering, the life of an engineer is very different than the life of a student engineer. And that, you guys, I doubt any of you sit down and solve calculus problems in the course of your general day as an engineer.
No, I didn't want to. I didn't want to say that. Yeah, for me, I don't. I use Excel like 90% of my day, and then if there's some complicated math problem I need to solve, there's plenty of like online calculators and programs that solve all that stuff for me. So you really just need to understand kind of the fundamentals, and you can't blindly trust calculators. You gotta kind of know if whatever is being spit out at you kind of smells right, if that makes sense. But yeah, you don't have to go and solve math problems all day long. So yeah, good point, Carl.
Well, I guess what I was getting at is that the creativity comes from understanding those underpinnings of math, but not by just doing, not like being a robot solver of problems. It's like the creativity comes from all of that experience, gives you like
totally. And then
yeah.
And then sometimes you'll still end up solving a calculus problem when some electronic board with some motor is asking you to figure out some angle, and you're like, oh fuck, I have to do this, and then you know how to do it. But yeah, no, you don't. It's also knowing, as I've always said, like knowing how to learn, knowing where to look for, knowing where to look for the information. And, one other thing that I guess I didn't mention to my to the previous class was one thing that I've done at Cabrillo, and then when I transferred a lot, was whenever I finished a class that had a TA or a tutor or something that would pay, I would try to become that tutor the next year, because first of all, you get paid, and second of all, you actually really learn the thing when you actually teach it to someone else. And so that really helped me get my bases really solid, because I kept trying to be a TA or a tutor or work at the MLC, PLC, whatever, constantly trying to reinforce the class I just took. So
Yeah, I totally agree with you, Julian. Like, as soon as like you teach like the aspects of like everything to someone else, that's when you actually know like the details of everything. Like, you're trying to sit here and explain everything. Like, that's when you know the material. So
That was one thing that during my interview, the person that I interviewed said, they said, try to help your teachers do like grading or something like that, because you'll learn it even better. You're going to get so much access to the material. That was something that I learned during my interview. That was a really great point.
that's great. Yeah, I agree with your interviewer. So
I had another question. Oh, sorry.
Go ahead. No, I was just going to say, in my college career, I broke my ankle and I was doing distance learning, and I still graded papers because people would just bring them to me and I graded that. So anyway,
yeah, I never thought that was something that I would ever want to do, but now I know when I get the chance, I'm going to definitely jump on that, because I will definitely, I'm going to use it as a learning opportunity. And I always said, when you can explain something to someone, it's just the next level of understanding.
Exactly. And I've always found that the end of the semester is the best time to ask a teacher, because that means it's one thing off their plate that they have to figure out who's going to be the grader next semester or next quarter. You're like, hey, I'll volunteer. I had a pretty good grade, can I please do that? And they're like, yeah, sure. I don't know if that's my strategy, but Carl, I don't know if that's true.
No, that is true. Yeah.
This is for either one of you, Julian, Josh, or Hannah. It's just like, what is your favorite and least favorite things about your job?
HR, or like all the non-engineering stuff is my least favorite, and the engineering stuff is my favorite. I get to play with 3D printers. I didn't tell this class, but this is actually the project the last product I've developed, which is a high-end noise canceling headphones for exactly this situation of online video conferencing. And so I don't know, I love working on what I do and getting to, like Hannah said, like work on objects and innovate, and seeing my work in the field and being used is always very satisfying.
I have a question. Hannah, or for any of you, for Hannah is, did you ever feel, or did someone make you feel intimidated being a woman in engineering? Or did anyone of you felt we're going through some imposter syndrome during your studies?
Yeah, I'll chime in. Just a comment about imposter syndrome. I think, well, there's definitely been a few times where I felt imposter syndrome pretty strong. And I think the first time that I really felt it was going into Cal Poly. I felt like Cabrillo, there was definitely not very many women in engineering at Cabrillo, and that's what you're going to find, in the field, and also, at a four-year school. That's just how it is right now, and it is getting better. But the first time when I walked into a class at Cal Poly, I looked around and I felt kind of maybe a complex, because I had a complex a little bit, just because I was one of the only women in the class. I think there were maybe 2 total in a class of 30. And then looking around, I didn't know who was a transfer student, and I kind of felt like, I went to a junior college versus all these kids. They got in out of high school. They must be smarter than me, or whatever was going through my mind at the time. But you know, I use that kind of as motivation because, you know, a lot of the folks in my class, they had been working on computers, I found out, since they were kids, and they knew immediately when they graduated high school that they wanted to become an electrical engineer, and that wasn't my reality. But I use that as motivation to work harder and to show that I am capable. And yeah, I continued to use that every time that I felt like maybe, you know, this isn't the place for me. I just used that as a challenge and motivated myself to just keep going. So that's kind of how I responded to feeling like an imposter in a way. But go ahead.
Anyways, Cabrillo College taught me the basics, and just follow the mainstream of what you've been trained to do. I mean, like it is hard for any of us to transfer to. I transferred to San Jose State University. Julian transferred to UCSC. I mean, but the thing is, like, Cabrillo College taught us the basics, and just know the basics, and you can go on from there. I mean, it's a struggle no matter what. I mean, but just keep going. I mean,
yeah, I'll Josh, I hear you. I'll just say that as a man, I can't understand where Hannah is coming from, and I can see that in the field where, like, I definitely don't work with a lot of women engineer, and I think that's sad, but and we work towards that. And so yeah, my personal experience is I've had some imposter syndrome transferring, same idea as Hannah, but obviously not on the same level as you have. I had, you know, different experience being from France, English not being specifically my first language, some you know, issues there, but I don't know what else to say about that. Yeah.
Maybe just one more thing I want to add is if you can just push through and, you know, figure out a way to respond to maybe feeling imposter syndrome in a positive way. You know, there's so many opportunities out there. For example, at Cal Poly, since, you know, at Cal Poly and really any school, there was a shortage of women engineers. There was a club that was called WISH, which was Women in Software and Hardware. And there were so many industry sponsors that would come by and visit this club several times a year to give presentations and provide mentorship and provide opportunities like going to conferences. And that's actually how I was able to get my job at Intel, was through a conference called Grace Hopper Conference for Women in Computing. And that conference in particular, there's, I want to say like 10,000, like some crazy number of women engineers that attend this conference. And there's a career fair, and there's so many companies that are trying to increase the number of just diverse candidates that are coming in. So I know it's kind of hard for me just to say just try to get through it, but really just try to get through it, and there will be rewards at the end. Same thing goes with, there's some other groups, not just, actually WISH I don't think is at every campus, but there's also Society of Women Engineers that I encourage you all to look into, as well as SHIP, which is Society of Hispanic Professional Engineers, and NSBE, and I think I forget the acronym, but the B part at the end is Black Engineers. National something Black Engineers, and those three groups should. Thank you. Those organizations should be present on pretty much any college campus.
You don't have to be a woman to join the Society of Women Engineers. Weirdly, I was part of it.
Yeah.
And right, we have various clubs, like we have the WISE club, the Women in Science and Engineering. I think there's a post in the Canvas page about starting a SHIP chapter here. And the other thing I would say is, like I went straight to UC Davis from high school, and I was one of those people that was considered gifted. It was easy for me to get through some of my classes, but everyone has a point where their natural inherent talent comes in it's not enough. You have to learn how to work hard. And so I think one of the reasons that Cabrillo students are so successful when they transfer is that they've already gone through that. They've already, a lot of our students have already tackled that, what you consider an imposter syndrome is really actually just coming up against a hurdle that wasn't easy for you and you made it over it. And so when our students transfer and other students for the first time in their life are being challenged intellectually, our students are like, whatever, let's team up. Let's find a way through. Of course we can do this. There's 100,000 other students that pass through this program and we can do it too. So there's a bit of magic that comes from working with others and, learning how to learn from others without sacrificing your own participation in that. It's kind of the difference between being in a group where you're not an imposter, you're contributing. And so you have to recognize your value to your own.
If anything, when you transfer, you will be an imposter because you will be ahead of everyone else.
Exactly. I totally agree. What I've learned at Cabrillo was so amazing. Once I transferred, it was like I was ahead of everyone. That's how I felt. So
yeah.
Thank you. So it's
Yeah.
just reaching out, finding a community when you're feeling it.
Yep, definitely. Carl articulated it perfectly. Thank you.
Thank you, Hannah.
So I have one quick question for Hannah. Regarding that you went ahead and pursued your master's degree, and you were talking about return on investment being pretty good in the engineering field. I was curious, for engineering jobs right now in California and the United States, how necessary is it? It's obviously beneficial, but how necessary is it to go to pursue master's versus the bachelor's level in terms of the job opportunities that are open to you?
Yeah, I don't think that it's necessary, but I'm really happy that I got my master's because realistically, I think we talked a bit about this in the last class. So I know, Josh had some inputs on this too, but just speaking from my own experience, I knew that I wouldn't really want to go back to school once I was working. And this was kind of, someone mentioned to me, after you graduate from college and you start getting a high paying job and you start, maybe, I don't know, you get a car, you buy a house, it's really hard to go back to school when you have all those things you have to pay for and you're used to living a certain way. So I just knew for me, I wouldn't want to go back and do that. So I'm really happy I just added on another year. And I think that just opened up doors, to be honest with you. For Intel, for example, we just hired on my team someone from Cal Poly that I helped recruit who had a bachelor's, and they came in as what we call a grade level 3. Versus me, I came in with my master's and I came in as a grade level 5. And the difference between a grade level 3 and 5 can be, say, $10K for a starting salary. And just the opportunities, I think, when you come in with just a bachelor's, you might not be given the same opportunities the master's shows that you can work a little bit more independently on a project. And maybe you'll be given like a more responsibilities for a project in a bigger company. That's just my observation. Now, I want Josh to chime in because I think he's going through his master's right now.
I'll chime in before Josh real quick, just to say that. So I don't have my master's, and I have someone that was hired for the similar job that I did at the same time. And as Hannah said, it was a $20K difference just to have the master's. No difference in job responsibility or knowledge. So
No, yeah,
put that out there.
Yeah, like there, to have a master's and a bachelor's, like the difference is, I feel like is like experience, the experience in the field. Like you can be like a master's and like that gives you extra knowledge, yes. But to work in a team environment is the ultimate goal, and like to fix the problems and situations. Like I felt like that was the ultimate goal. Like we're trying to fix things one thing at a time, you know, and we're trying to solve situations. And if you had an interview with a master's, or if you had an interview with a bachelor's, like I really, if it's my like consensus, like it doesn't matter. I mean, you work hard for your master's, you work hard for your bachelor's, you work hard for this, that, and everything. But I'd rather have someone that can work with me in a team environment. So that's what I'm thinking of. So.
Right. So
Yep.
yeah, if you have the opportunity, if it's something that is easy, like Hannah's, like 1 year and stuff, I would definitely say go for it, because ultimately you might, I'm not sure if it'll open more doors, but the doors that will open will have a little bit more cash associated to them.
Yes.
Fair enough.
But you know, as far as I said, like I don't have a master's, but I don't feel like it's inhibited me at all. Especially, except maybe for, as I said, pay levels.
Yeah.
But
There's no preference. Yeah, like as long as you can work and want to work in as a team environment, like I'd be awesome to work with you. So.
Okay, thank you guys.
There are certain jobs that require certain degrees.
Right.
They're pretty
Right.
isolated. Like to teach, you need to have a master's or more, and like, but a lot of times it has to do with that responsibility piece of it, right? Which is sometimes you need to have the confidence to say, yeah, I'll come in and lead a team of 5 people to complete this project, and that doesn't necessarily come from whether you have a master's or a bachelor's. It has to do with your sort of confidence in the, you know, and that goes back to the imposter thing, which is our students have the confidence to tackle things they didn't think they knew how to do and succeed in them. And after a while you get used to, of course I can do that. Of course I can do that. And I know even in my interviews now, like I don't worry about knowing everything that they ask me about. I know that I have hundreds of examples of not knowing or transitioning from not knowing something to being able to know it and be creative and fluent in that topic in a very short amount of time. And that's the kind of idea of learning, and knowing the difference between sort of a superficial ability to pass a test and knowing the subject matter enough to make something using that subject matter. And I think our students really are exceptional at experiencing that difference viscerally. Like they know the difference between, I passed that test out of pure luck because it was lucky for me, versus I absolutely know this material and I didn't get that question right, but that's just like, you just shrug it off because you know the material, you know? So anyway, I know we should let our guests take off, and I know we still have some things we want to do in our class. So why don't we thank our guests for coming in? So a round of virtual applause for them to come
Thank
in
you
and
all
talk
very
to
much.
us. And
guys.
let's go ahead and take a 10-minute break. So come back at 5:50 and we'll pick up and work on our project. Thanks, everyone.
Yeah, thanks, Carl, for the opportunity to come speak to your class again. And I put my contact information in the chat window, and anyone, please, feel free to contact me if you have any more questions or just want to stay in touch. I'm happy to, exchange emails or answer any more questions over the phone if you guys want to set anything up later on. So, yeah, thanks.
Okay. Thank you, Hannah.
I'm
Same
off
for me. Yeah, I'm posting my email, and you guys can contact me with whatever you need.
And we have a little over an hour to go. So I'm going to kind of jump to our project. There are some slides up there about the different fields of electrical, computer, software engineering. And I think you guys have talked about those in other classes with Preeti as well. So I'm gonna just kind of jump to the project. I hope that you get a lot of value of having our kind of alumni come in and talk to you. I can kind of adjust that. So if you have any concerns about like it's too long or too many or whatever, let me know. You don't have to write it in chat or anything, but just let me know and we can try to tune that to your needs. I always really like to hear from them and what they're up to, and but I understand that other people have different needs. Okay, so let's go ahead and I will share my screen and jump over to our web page for our class. I'll go to modules. And I'm going to show these slides that are under coding or codes and coding presentation. And then after that, we'll talk a little bit about the project itself. Let me close the door here. Just one sec. We're on competing Zoom sessions right now in the house. Okay, so let's go here. I will open this up and go to presentation view. And so the goal here is to talk a little bit about sort of the underlying principles of how computers work. And that has to do with sort of understanding how codes work. And then when we talk about coding kind of in a modern sense, what that means as well. So the kind of big picture behind all of this is that information can be stored in various ways. And if we go and explore something that you already know, language, we can hopefully get a flavor or a feeling for how this all kind of plays out in our own minds, really. So there's a study called semiotics, which is sort of this idea of how signs and symbols work with respect to the human mind. But rather than go through this really abstract idea, let's look at something a little more concrete. So the idea is that in the real world, there is a real cat. And I used a picture of a cat, which is a sign. It's not really that cat. That's not a cat. It's just a picture of a cat. But out there in the world, there is a real cat. And so when we are thinking about a cat in the real world, that is referring to that cat, and that's why it's referred to the referent, and then we're kind of thinking about that cat. And then when we are communicating with other people, we're using different symbols. So we could have symbols that are written like cat, and that can be in different languages, so gato. And then we have in parentheses, right, or in quotes, I mean, there's actual, the sounds, the vibrations for the word cat. That is another way we communicate it. Or we can use symbolic pictures as well. So there's kind of a symbol picture that is unmistakably a cat. And so somehow all of these things, like there are different ways that we're referring to this concept of a cat in these different environments. So a code is really used to, you know, these are dictionary definitions. So let's look at the two of them here. It's a system of signals or signs, if you will, used to represent letters and numbers in transmitting messages. And it's a system of symbols, letters, or words given arbitrary meanings used for either hiding a message or to make it more brief, right? So these are kind of the dictionary definitions of code. But let's look at a few binary codes. We know that computers function in binary. So let's look at one of the first and most important kind of technological codes, which is Morse code. And Morse code is it's a binary code because it has two different signs that everything in it, all the letters, all the numbers consists of some pattern of a dot or a dash. And you probably heard this like, I have no idea what I said. I apologize if it was rude. I don't know Morse code, but the idea is you probably heard this. And the way it kind of worked was you had in one part, let's imagine you have a light switch probably in your room somewhere or somewhere in your house. And when you switch that light switch on, it completes a circuit and allows the electricity to flow through the light. Well, the way a telegraph would work is you had a switch called the telegraph key in one location, and the electricity would go through a long set of wires. Say I'm in Santa Cruz, so maybe it would reach all the way down to Watsonville. And when I click the key, this little clicker on the other side would respond because the electricity is going through that loop. So it's a lot like if you imagine having a light switch in one town where you flip it on and off and it turns on a light in the other town. Now it wasn't a light, it was a auditory signal, so you could listen to it. And there was a job where people would learn this code and they would translate all the messages for you. And if we go back to the code itself, you'll see that it was structured around the way human beings work, and human beings don't like the tedium of, you know, they want to be efficient. So you'll see that the letters that are used more often, like the vowels, A, E, I, N is pretty common. Those only take two symbols to indicate, or even one symbol. And then as the word letters become more esoteric, like J, it would take four symbols to communicate that letter. And this was done basically because of the way human beings kind of function. Another binary code that we can come across often in society, and particularly like if you go to an ATM, you'll definitely see Braille there. You'll see Braille in elevators and other kind of public spaces. And it's this set of raised dots that indicate letters, and you can see here's different Braille representations of different letters. And so that's something that you can learn that code, and people learn how to use their fingertips to recognize those different patterns. And so as they drag their finger over that set of dots, they can quote unquote see the word the same way that you kind of see the word when you're interpreting the layout of all those light and dark spaces, or, you know, like where the dots are. Not the dots, what are, you know, like, I'm thinking of pixels, that's why I'm getting caught up. But like we see A, B, C, and D on there, and somehow our mind is converting that for us. And your finger it has the same kind of sophisticated dexterity or dexterity isn't the right word, but the sophisticated sense of touch to be able to interpret those different dots. And people can be incredibly fast at reading Braille once you become accustomed to it. Another binary code are these UPC symbols that are on products. And you can see both the kind of thick line and the thin line. And that pattern allows us to represent the number that's below it. So it has both the human readable form and the machine readable form. And these are all just different codes. Now, let's zoom back out again to this big picture. So information can be stored in various ways. So we know that computers store all the information that we're familiar with in computers is stored as ones and zeros, right? It's kind of like a theme of, I don't know, popular, I don't want to say popular science, but popular culture is this whole ones and zeros thing. So when we think about everything that we're accustomed to working with on a computer, whether it's video, a picture, audio, video games, all of these things are just constructions built out of a set of ones and zeros, a set of different symbols. And so because of the way that we can represent, you know, all of this different information as series of ones and zeros is really what allows the sophistication of our modern computer system. I am going to introduce another, oops, let's go back. Let's talk a little bit about another machine called the teletype machine. And this one is important in my kind of thinking about the transition to modern computation, because if you look at the columns over on the right-hand side, you'll see there's punctuation marks, there's numbers, there are letters and uppercase letters and lowercase letters. But over here on the left-hand side, you have 4 columns that are the ones and zeros that represent each of the rows. And then you'll see at the top, the set of 3 ones and zeros that represent each column. So the teletype machine is sort of like a remote typewriter. So just like the telegraph key would allow you to, you know, click out a pattern in one location and you would hear it in another location, the teletype machine was a machine that you could type in one location and you would get a duplicate of that, what you're typing on the other side. But a typewriter has more to it than just the symbols. You have to advance. You have to scroll the paper up. You can like go backwards. And so these 2 columns where it says like NUL and SOH and STX, these are all commands. So they like LF is line feed. It means go to the next line. Form feed. So there's all of these different symbols that represent like an action on the other side. And this is where you start to see that ones and zeros can represent data, like letters and numbers and pixels and colors and sounds. But there's another kind of information that you can store, which is instructions. And that's where our modern thought about programming really comes from. So if we look at a game like Pong, and I discovered last time, I think that this doesn't work. Let's try. It doesn't seem to be working. Anyway, I will go back to my, oh, there it is. Oh, it's the Flash player problem. That's what it is. Anyway, Pong is sort of like a simulated ping pong game, or, oh, you can kind of see it over here on the edges of the screen. You've probably seen these games at some point. We don't have to spend too much time delving into them right now. Let me get rid of this. We'll go back to our slides. But the idea of Pong is that you have 2 paddles that move up and down and a ball that's bouncing between them. And so if we wanted to deconstruct that game a little bit, what are the different kinds of information that we would have to store in order to keep track of the game? Let me give you maybe an example. Let me get your faces so I can see them. I'm having a lot of trouble with my Zoom situation here. So for example, I want to keep track of the score. So I would have to have information that keeps track of the score. I would have to consider, like, where is the ball position. And the ball position would be stored potentially as an X value and a Y value. I would have the movement of the ball, like its velocity. And for those who have been through physics, you know that velocity is actually a combination of two things. It's a speed, like miles per hour, but it's also a direction, like north, south, southeast. We would have to know the paddle position. Let me change the position of this. So this is all kind of data. And there's other kinds of data that we would have to keep track of as well, but I'm just trying to give the basics. So what are some of the behaviors that we have to keep track of? Well, for example, not the score, but the scoring. In other words, when the ball gets past the paddle and exits the play field, you have to count an extra, you have to increment or put another, point in someone's tally. There's scoring, there's the bouncing off walls, there's bouncing off the paddles, there's the sounds, there's the ending the game, etc. So I guess what I'm trying to distinguish is this idea that there's information that's stored that is like the representation of the state of the game. So there's, another one here would be the graphics, right? The actual images.
I'm not sure how you'd characterize this, but like the the sensory or perception of the motion controls and how that communicates into the movement of the paddles.
Yeah, that would be in the behaviors. So the user input or the input device.
Okay.
I'll call it input translation. Because the classic Pong game, you can see there, it's a little hard to see, but you have these two knobs. And the way that it would work is two drunk people in the bar would each put you put a quarter in there, and then you'd have your epic ping pong battle over Pong. Kind of joking there, but I mean, it was one of the most popular games in a bar environment. But you have to get used to the idea that you're turning, and that's creating a linear motion, which is not it's not an insignificant thing. People had to train themselves to understand that concept. If we go a little bit further along, oh wait, I got to stop doing my, I got to actually go to the next slide. If we looked at, I got to clear my annotations. If we get to a slightly more sophisticated game like Mario Brothers, right? You have, there's a foreground and a background, right? So if you played this game and you jump, like if Mario jumped right now, he'd hit his head on that brick, and that brick is like, in the world, it has a behavior. So when he jumps and hits it, it would break the brick. And when he hits the little question mark, it would potentially output a coin, or it might be, there's various things that interact. But he can run right through that mountain. He's not running up the mountain. He's running right through those bushes that are back there. So the computer is keeping track of it decides the behavior of this world. And that gets, it gets more and more complicated. The input is a little more complicated. You can go forward and back. You can press the jump button. You can press I don't think he's Fire Mario right now. He's just Big Mario. But if you got that fire flower, then when you press the other button, he can shoot a little fireball, right, that goes and knocks out the evil creatures, the Koopas and the piranha plants and the other stuff. So as these games evolved and as computer software has evolved, you get to a point where, oh wait, I got to do this again. I don't want to annotate. I want to go to the next slide. And these are already kind of pretty old because they're Xbox 360 games, but you have a game like Minecraft, which is really almost completely about data. There's not, at least when it originally started, it didn't have like a story mode. It didn't have cutscenes. It was kind of like this free-for-all playground of different, types of square boxes that you could craft together to make other kinds of materials and other objects and things, as opposed to Halo, which is produced almost like a movie. So it still has behavior and data, but it has a lot more prearranged data. So computer programs always kind of is this dance between programming behaviors, and then those behaviors oftentimes are modifying the data. So the most fundamental structures of a program are these three. There's something called a sequence, a selection, and a loop. So we're just going to take a minute. Actually, I think it's about 2 minutes, and watch this video because I think it's a good introduction to, they have really good examples in here of these different structures. So I'll go ahead and play it. Oops, that did not work. Let me go back. Present, play. There we go.
Behind all of the software that we use on a daily basis, there's a code being run with all sorts of different terms and symbols. Surprisingly, it can often be broken down into 3 simple programming structures called sequences, selections, and loops. These come together to form the most basic instructions and algorithms for all sorts of software. A sequence is a series of actions that are completed in a specific order. Action 1 is performed, then action 2, then 3, etc., until all of the actions in the sequence have been carried out. A sequence we do every day is a morning routine. You might wake up, drink some water, take a shower, eat breakfast, and so on. Everyone's routine is different, but they're all made up of a sequence of various actions. Selections are a bit different. Instead of following a specific order of events, they ask a question in order to figure out which path to take next. Let's say you go to brush your teeth and you find that you're out of toothpaste. You then ask, do I have any more toothpaste? If the answer is no, then you would add it to your shopping list. But if the answer is yes, then you would just use the toothpaste. This is really all a selection is doing, answering a question based on what it finds. The third programming structure is a loop. Like selections, loops also ask questions. However, the difference is they ask the same question over and over and over again until a certain task is complete. For example, take the act of hammering a nail. Even though you may not realize it, you're constantly asking yourself, is the nail all the way in? When the answer is no, you hammer the nail again. You continue to repeat this question until the answer is yes, and then you stop. Loops allow programmers to efficiently code repetitive tasks instead of having to write the same actions over and over again. These 3 programming structures may seem fairly simple on their own, but when combined, they can create some pretty complex software.
GCF Global.
So those basic structures really do encompass the heart of all programming. It's doing a series of steps where you don't skip any step, you follow through every single one. or a sequence or a selection where you're making choices. The computer's asking questions, and then based on the result, it does one thing or another. So if we go back to the gaming example, it may be simply, it will take a different action based on whether you press the A button or the B button, right? So it's like if the B button is pressed, then jump. If the A button is pressed, then swing your sword. If no button is pressed, then don't do anything. And so it's constantly asking these things about the kind of environment of the game and responding to them. And then loops. Loops are, there's kind of a time loop going in a game all the time. It's like it's taking, probably if there's gamers in the room, you think about things like frames per second, how fast can your video card render things, and all of those things come into play. And that's indicating that there's a loop going on. It basically says, I'm going to take a moment in time, render the screen for this moment, and then I'm going to go calculate a fraction of a second later and do that whole process of rendering that next moment. And it goes through, and it's going through a loop to basically create the illusion of time passing in the game. So the project today is to follow one of these hour of code tutorials. And I recognize that we're probably, let's see, what time is it? Oh, 6:17. So we don't really have an hour left in the class. So you could get started today and finish today if you want, but you have until next class to complete this. But I did want to go through just a little basic example of one of these hour of code projects. And so we're going to work on one that is about drawing. So let me get started here. All of these hour of code tutorials, the ones I selected for you, have a tutorial or a video or something to help you through the process. So the first idea here is that I am, here's the assignment I have. I wanna make a square using a couple of different functions. I can move forward and draw a line as I'm moving forward. I can turn right, or I can turn left. And by manipulating these things, I could decide how many degrees I turn, or how far I walk. So for example, if I wanted to make this square, I could take and I drop it in here, and it is just saying from this little guy over here on the left-hand side, move forward by 100 pixels. So when I click run, you'll see he went from one side to the other, but then the program ended. So I didn't complete the task, but at least I got something done. I'm on my way. So if I was sitting where he was and I wanted to draw that line down, I would need to turn to the right. So I would then add this, and then I would move forward another 100 pixels. So if I reset and run this, I'm almost to making a square. I could turn right again, walk another 100 pixels drawing my line. I can already predict that to finish up, I would turn right one more time, and then I will walk another 100 pixels. And when I reset this, I've gotten to the point where I can make a square. So this kind of coding, it's called block coding. And I'm using these little graphical things, but I can show you the real code beneath it. In other words, each of these is a programming statement in the underlying, the kind of infrastructure of the internet is built on a programming language called JavaScript. So these are JavaScript calls to make that drawing. And so as you work your way through these challenges, you'll get more complex as you work your way through. Here, I'm going to make a diamond. So the complexity here is I have to make different turns, but they're all 150 pixel sides. So I could do this one, but rather than walk through all of these, I'm going to kind of skip some of them and get to the ones that start to exemplify some of the things I want to show. So here, I would, in order to draw this hexagon, I know that I'm going to have to make 6 steps forward, and at each time, in between each of those, I would have to make a turn, right? And it's starting to become really repetitive, right? I have to move 100, then I have to turn right, and I turn right not by 90 degrees this time, but I turned by 60 degrees, so I could go ahead and set that. Then I would move forward, then I would move right. Oops, I didn't place it correctly. So I would set this at 60 again, and you can kind of see how this is playing out in terms of the drawing. I just have to keep repeating that over and over again. You're probably realizing why loops exist. This is stupid. Why am I doing this? This doesn't make any sense. Oh, wait, I did the wrong thing. Let's make a move forward. So I move forward by 100, then I turn right by 60. So I'm repeating the same thing over and over again. So as we move forward through these challenges, we'll get to a point where they introduce this concept of a loop, right? So what I can do is take this repeater programming functionality out, and I can take and put my instructions into it. So now, rather than have to write move forward, turn, move, turn, move, turn, move, turn, I can just simply say move, turn 6 times. So when I run this program, it will actually complete the hexagon. And I can look at my code again. You can see it has, this is how it's doing the counting. And this is where it's also making the decision of whether to stop counting or doing it. But you can see my move forward and turn right are right here, and it's wrapped in something called a for loop. As if you're gonna pursue like programming, you'll eventually get to understand all of these little pieces. But I wanted you to kind of have at least an example of how these all fit together. The puzzles get increasingly more complicated, right? So this one, all of that work draws one of these little segments. So if I wanted to draw the whole figure, I can kind of guess that I must have to put this here, and then I have to take all of this junk and put it in here. But then I have to figure out how many times it's going to happen. So, you know, you can kind of like, as a human being, you can walk through the steps and predict the motion. And the way this is structured, it moves, turns, moves, turns, moves, turns, moves, and then it comes up and moves again. So when you watch its motion and try, like watch its motion in this repeat, let's go ahead and repeat this. How many times do I want to repeat this? It looks like there are 1, 2, 3, 4, 5, 6, 7 points. No, 8. So probably 6, I'm guessing. Either 6 or 12. Let's find out. So I didn't get all the way through, so I'm going to go ahead and say, oh no, I must have to do 12 because I missed 6 of my points. So I'm doing debugging right now. I'm looking at the results of my program and finding out it didn't do exactly what I wanted, so I can make a change and then I run it again. And I can decide how fast it runs. I can turn up the speed. So indeed, we finished. We look at our code, and it's taking those basic structures and extending them. Here, there is a change in that you're changing the color as you draw, and you can see that that's, you know, kind of laid out here. So each time I run it, it draws 1 petal, and the top portion of that petal is different color than the bottom portion because of the set color command here. The puzzles get increasingly more complex, and the solutions also get a little more complex. but eventually you get down to, like, this looks pretty crazy, right? So the challenge here is to kind of predict what it's going to do, but actually let's step back a step. So this introduces this concept of a function. So a function is a set of code that will do a whole task. So in this case, the task is to draw a flower. So the draw a flower task is laid out here. So when I run it, it will draw one flower. And you can see it may not have drawn the flower the way you expected it to. In other words, it kind of followed a geometric pattern rather than just like drawing each petal independently. But in any case, it drew a flower, but it didn't go through. So now I have to look at the other things that I have available to me. So I figure to get down to this next flower, there's going to have to be a jump involved. So I can, you know, take and I can move this out of the way. I can have a jump, and then I probably have to do a turn, and then I have to do another jump, and then I can draw another flower. So the function repeats the drawing process of the flower, and then this is the sequence to get to the next one. I'm kind of guessing this is right. We'll see. You never know. Oh no, I was totally wrong. Holy moly. Oh well, I guess I'll have to keep working. But, and I will stop now because I want to give you some time to work on this project on your own, or I can break you out into different rooms. But each of the projects that I've set up in the module is, I tried to pick these particular examples because there's kind of this artist inspired one that's for doing like a graphical thing. There's kind of like a Guitar Hero type of game that is trying to get user input and then respond to the user input. There's an App Lab, which is to make a sort of smartphone styled application. RoboBlocky, which is using that kind of block code that I was using in that example to control these virtual robots and perform tasks. Then there's kind of a music game. So the construction of music is very similar to this. You follow patterns and you go through loops. And then there's also one to make a sports game. And if you have experience programming, you can choose from any of these Hour of Code projects, but I wanted to pick out some that I thought were like well within the reach of anyone that's just walking into this new, because the whole idea of the Hour of Code is that someone can go from not really knowing anything about coding to making some progress in that hour. And so this is, you know, about participating in the tutorial, and it will count towards your tutorial points or your points within the class. So let me stop sharing so I can see people's faces again and ask you if you have any questions or concerns or comments about going through this project. All good? Okay, so if you want, you know, you can go ahead and work on this on your own. You could work on it right now. If you want me to set you up in a breakout room with your friends to work on it, I'm happy to do that. There's a lot of ways that you can kind of move forward in this. Oh, you know what? I do need to do one more thing, and that is to go back to the website, and I want to talk a little bit about right, we have this interview and engineer project coming up. And I had a few questions about it. Oh, I'm not sharing, sorry, my bad. Let me share again. In this project, remember that the viewer that you are, you're not producing this for us, you're producing it for the other students. So when you're deciding what to consider in all of this, we've kind of given you a structure and suggestions of how to put it together. But really realize that your audience are your your fellow students. So share the things that you thought were most interesting for a student and kind of work from there. The other parts of this is that we're going to, you produce this presentation, and we're going to have the submission kind of broken up in two different pieces. So for this assignment, you would upload your summary of the typed up summary of the 15 questions. But when instead of submitting your video here, and I know we have at least one student that did that already, and I'm just going to ask you if you could put it over in this discussion board. And the reason is we want these to be accessible to the other students so that you can take advantage of, like, oh, I got to talk to a materials engineer, or I got to talk to a biomedical engineer. And you'll have a chance to kind of review the other videos and see what variety of experience that, that other people, that we can learn from each other. So there's another discussion board thing where you will actually put your video. And you'll get points for putting up your video, and then you'll also have some assigned peer reviews, and you can also comment on these. So be sure or feel free to kind of make this a little more participatory than just producing a video. And again, make sure you recognize that your audience are your fellow students, not your instructors. We're not here to have a dry, boring presentation about this. Like, try to share the things that are interesting to you. You don't have enough time to really, cover everything that we ask for. So focus on the things that you thought were most interesting and most important. Any questions?
I've got one, Professor.
Yeah.
So under that assignment, let me go to it real quick. For the video presentation, there we go. Okay, so in the beginning it says just to do a phone interview, and then do a slide show, so I'm assuming that's PowerPoint.
Yeah.
So we're submitting the 15 questions in Word format, then we're doing a PowerPoint, and is that where we record ourselves talking about what we learned, or are we just doing a video of our face?
The slides, we're hoping that you can use the slides and your face at the same time, right? And that's what, there's a couple of different examples using the one called Screencast-O-Matic. There's another one in the interface for Canvas itself. A lot of you already have some sort of tech that allows you to make videos. If you're really, you could print out your slides and hold them up like this and talk about them. A lot of it is like just doing your best effort, as opposed to meeting a whole bunch of different like individual criteria from our perspective. So we understand that there are tech differences between all of our students, and that some people have webcams, some people don't. You may have to borrow a friend's, or a family member's computer or something to do this. So just do your best. And if you really run into something, like Corey is talking about, I think it talks about how you can screen share and record on Zoom. So you can use Zoom. You can get a free account on Zoom to do that. I guess we all have them, right? Basically, to use this, you have the Zoom account. So just because we outlined a few different methodologies there, we recognize there are many, many, many methodologies for doing that. Most computers come with video editing software. Do your best, but don't, if you get kind of caught in a trap of having a super concrete vision of how this should work, let go of that a little bit so it's a little more pleasurable of an experience, and recognize that like little slip ups and errors and mistakes are what separate us from the robots that will eventually take control of everything.
Hopefully not too soon.
Yeah, hopefully.
All right, thank you.
Okay, yeah, of course. Any other
Well,
questions out there?
oh yeah, so that's good to know. So like with Screencast-O-Matic or Zoom, with those ones, we can basically record a screen share while it's simultaneously recording our faces, and we can just kind of narrate as we're going through it.
Yeah.
Okay.
Yeah, I've done kind of a dry run of it, and it works pretty good on Zoom.
Okay, great.
Awesome. Thanks for that testimonial, Corey. It's doable. Yeah, one of your peers have already finished it and uploaded it, and it looks great. So, but don't get caught off guard like by this assignment. It's, you know, it's starting to come up, and it's a pretty significant assignment. It's worth 15% of the whole class grade. So it's kind of the equivalent of a midterm. So make sure that you do it. And I will be spending some time, you know, looking through the submissions and making sure everyone's on track to complete the class. And so you might get some emails from me if I feel concerned that you're falling a little bit behind.
All right, thank you.
All right. Any other questions, comments out there? Awesome. So I'll stop the recording and I'll be around. So if you have questions, if you're working through the tutorial and you have any questions, I can certainly help. But you're also welcome to do that completely offline. You don't have to stay on Zoom just to go through the tutorial.